Can you do it? Hi guys, happy Monday. This is week 5. Sitting here with the newest addition of the family. This is Arthur. If you remember, I missed some days back in November. Had something to do with this guy. He's now 5 months, almost 6 months, so he's able to do a lot of stuff like sit up on his own. He's got a couple of teeth coming in there and he's grabbing everything he can. Maybe. My face. Okay. So, anyways, just a quick hi and then move on with the rest of our announcements. So, guys, not really that much to talk about this week. You guys are doing great. Just introduce the concepts overall. Last week we did surface area, which was looking at, maybe a die, and then saying how much area is each of the squares that make up the outside of that. We also did triangular prisms, which are a little bit harder because of the triangle thing. This week, we're going to go into pyramids. Our first lesson is about finding the surface area of pyramids. So, quick background knowledge. This is a pyramid. If you think about the wonders of the world in Giza, in Egypt, they have a bunch of pyramids there. Those are gigantic. And if we think about those, we know that they're like 3D triangles. But think about it more carefully than that. We know it has 4 sides. But don't forget, it also has a bottom. So as we find the surface area for this, we are going to really try to separate the shapes that we see. And that first starts with kind of cutting the shape apart. So let me carefully take this and cut my tape. Ooh, I'm ruining my pyramid. A little quick drawing on your sheets of paper, on your notes, will really help you this week. So this was the pyramid, but as I kind of unwrap it, you can kind of see what's happening. And what really do I have? I have a square rectangle in the middle with this style. This is called a rectangular pyramid because the base was a rectangle or a square. And then the other 4 sides are triangles. So if I give you the right dimensions for each of those, you'll be able to find the surface area that this would take up if you laid it down flat. That's what surface area is. And then in the same lesson, a little bit harder to visualize, are triangular pyramids. And this is what I mean by that. It looks the same, but when we look at this base, it's not a square or a rectangle anymore. It's another triangle. And so these drawings are going to look really hectic. But if you break it down into the net, it's going to be much easier to visualize. And you just slowly find the area of each of those triangles, and you will be good to go. So it would unwrap into something like this. You really want to be careful with this because one temptation is to say, oh, I'll just find one triangle and multiply it by 4. But really, that doesn't happen all that often. Most of the time, the base will be one size of a triangle, and then the other triangles are going to be maybe bigger, maybe smaller. I don't know if they could be. Anyways, just go slow with it. Don't make any assumptions like that. Measure each one and then add it all up together. And the second lesson is going to be finding the volume of different shapes. And the ones we're going to present to you are rectangular prisms or cubes, so they're going to be easier to find. But I want to rewind and say volume is the amount of space a 3D shape takes up. So area was the number of squares or the number of space that a 2-dimensional thing, like a blanket, how much space that would take up on the ground. But 3D objects take up more space. And you've heard of volume before. The most common place is like in beverages. If you look at it, it says down here, this one is 16.9 fluid ounces or 500 milliliters. The way volume was discovered, I can't help it each time we do this lesson, they were trying to figure out how much space weird things took up to see like which crown. The story is this: it's like Archimedes back in ancient Greece, and his king or something like that says, hey, I want to make sure I have the biggest golden crown around. And Archimedes is like, dude, I can't measure that. Like, it's got all these jagged edges and stuff like that. And he couldn't figure out the problem to say, how do I know that this is bigger than another one? So one night he gets in his bathtub and it's filled to the brim. And then as he gets in, he notices that water escapes. Water goes out of the bathtub. And he realizes, like, wow, that water that left the bathtub, that's how much space that thing took up. So he could then use that. So what we can do, I'll show you. I filled this cup up with water. And we know that these cans are 12 fluid ounces. Let me just show you how this works. It's filled all the way to the top. And so if Archimedes is right, the amount of space this can takes up, it should displace that amount of water out. And I've got this bigger cup to catch it. And then I'll measure it in here to see, yeah, is that about 12 fluid ounces? Okay, so let's just slowly try it. And the beauty of it is once it goes all the way in, like no more can come out, even if I push it down further and further. I have not tried this in a long time. So I'm going to drop it, and I'm going to give it a little poke. Careful poke. I probably made too much leave. All right, so I did that. I'm going to carefully pull this out. This is a little, I don't know if you'd call this science. But now, if I pour that in here, it's a little bit better measuring equipment. Let's see how many ounces were displaced. Oh my gosh, this is perfect. And of course, it's not too scientific, but if you can see this, it's right on the 12 fluid ounces line. So that's the amount of water that this takes up. So our other measures of volume that we're going to do have something to do with that. We're actually going to be finding the volume of much easier shapes with math. You don't have to do this at your house, but we'll be finding the volume of cubes and rectangular prisms given the different sides. And then our final lesson this week, lesson 3, it's going to be kind of a review, but adding an extra wrinkle to things. I don't know if you remember exponents. Here is a quick example of exponents. That was the small number that we would see to the top right of other numbers sometimes. My biggest thing is 5 squared is not 10. Okay, if you can remember that, then you're going to be good to go. It's always bigger than you think. 5 squared, or 5 to the second power, means that you have 2 5s that are multiplied. And so we're going to extend it by saying, can you do that with decimals? And at first you might be freaking out, but really it means the same thing. How many 3.3s are there? There are 3 3.3s. And then you'd have to multiply them over and over again. Okay? So not too wild. Shouldn't be too crazy of a week. The hardest lesson in my mind really is lesson 1. And so just be really careful with your nets, drawing out your different shapes that make up your 3D shapes, okay? Good luck this week, guys. Remember, always reach out if things are seeming tricky. And also, I've had a few students reach out and say, hey, IXL isn't working, so I give them a big ideas. Well, it's still your obligation to do that big ideas. If you don't do it, then you didn't practice. So we need to meet each other halfway if that's the case. All right, good luck this week, guys.